Okay, so in this next problem we're once again asked to evaluate the limit if it exists, and the limit we're given this time is the limit as h approaches 0 of x plus h cubed, the quantity of x plus h cubed, minus x cubed, all of that over h. Now the first thing we're going to want to do is do the binomial expansion of x plus h cubed, and you can either do that by hand, but I like to do that using Pascal's triangle. So what that says is that the coefficients of this binomial expansion are going to be 1, 3, 3, and 1. And then I'm going to write my xh here, my xh here, and my xh here, as well as here. And then I'm going to raise this to the 0 power, this to the first power, this to the second power, and this to the third power, and I'm going to work my way down. It might actually be the other way around. Let me try it the other way around. No, I don't think it is. Okay, so this is the binomial expansion written out. Now what I'm going to do is I'm going to multiply each of these rows across. So x to the 0 power is just going to be 1. So this first thing is going to be h cubed. And then x to the first is just x, so this is going to be 3xh squared. Then x squared is just x squared, and h to the first is just h to the first, so this is going to be 3x squared h, and then finally this is going to be x cubed. So that's the binomial expansion of this, so I'm just going to write it out like that now. Hold on, I wrote the limit wrong. The limit as h approaches 0 of h cubed plus 3xh squared plus 3x squared h plus x cubed minus x cubed, all of that over h. So then obviously this x cubed and negative x cubed will cancel out. So we're going to be left with limit as h approaches 0 of h cubed plus 3xh squared plus 3x squared h all over h. There should be a h right here. And now what we can do is we can cancel out an h from every single term. So what I'm going to be left with is limit as h approaches 0 of h squared plus 3xh plus 3x squared. Now we can directly substitute 0 for h. So we're going to get 0 squared plus 3x times 0 plus 3x squared, which will just be 3x squared. And that would be my answer to that one. Alright, so in this next problem we're told that if 4x minus 9 is less than or equal to f of x, and f of x is less than or equal to x squared minus 4x plus 7, find the limit as x approaches 4 of f of x. And this might seem challenging or daunting at first because you're not given f of x, but what you need to remember is that this is a squeeze theorem problem. And that basically says if you're given 3 functions and you know that one function, in this case 4x minus 9, is less than or equal to f of x, and that is less than or equal to another function, then if the functions on the left and the right of this inequality, if those approach the same value at a limit, then f of x has to be that limit value as well. So to explain this to hopefully explain this a little bit better, I'm going to draw a graph. So let's say I have this equation, or this graph right here, and it's oscillating like that. And then I have this equation right here, and this graph right here, and it's oscillating like that. So this middle function would be like our f of x, and this top function would be like this x squared one, and this bottom one would be 4x minus 9, even though these aren't linear or parabolic or anything like that. It's just to show an example. You can see that because f of x is squeezed between these two other graphs, it's going to approach whatever these ones are approaching at this value right here. So our job is to make sure that both of these functions approach the same value as x approaches 4. So first I'm going to do the limit as x approaches 4 of 4x minus 9. And I can just directly substitute 4 in for x. So 4 times 4 minus 9, which is going to be 16 minus 9, which is equal to 7. And then I'm going to do that with the other function. The limit as x approaches 4 of 4 squared minus 4 times 4 plus 7. So that's going to be 16 minus 16 plus 7, which is just 7. So both of these graphs will approach 7 as x approaches 4, and because f of x is between them, it's squeezed between them, we can also say the limit as x approaches 4 of f of x equals 7 by the squeeze theorem. Okay, so in this next problem we're asked to prove that the limit as x approaches 0 of x to the 4th times the cosine of 2 over x equals 0. So this is going to be another squeeze theorem problem. We're just going to have to apply it a little bit differently, because in the last problem we were given two functions and then an f of x. This time we're going to be kind of creating that ourselves. So what I'm going to do is I'm going to write cosine of 2 over x. That's kind of the tricky part here, is we don't know how to do trig limits. So I'm going to write the cosine of 2 over x, and then I'm going to make an inequality. So now we have -1 is less than or equal to cosine of 2 over x, and cosine of 2 over x is less than or equal to 1. And the reason this is true is because if you look at a cosine graph, cosine oscillates like this. But it only ever goes between 1 and -1. And there's no constant number like a 5 or a 6 or anything like that that would change that fact. So we know that no matter what we plug in for x, our answer will always be between -1 and 1. Now, it's a property of inequalities that they remain the same as long as you multiply by a positive number. And we know that whatever we plug in for x, when it's x to the 4th, it will always come out positive because it's being raised to the 4th. So I'm going to multiply every number by x to the 4th, or every term in this inequality by x to the 4th. So now I have -x to the 4th is less than or equal to x to the 4th times cosine of 2 over x and that is going to be less than or equal to x to the 4th. Now we have this equation right here, and we have our smaller function and our larger function that was a prerequisite in order to use the squeeze theorem. Now what we can do is we can evaluate the limit as x approaches 0 of -x to the 4th and +x to the 4th, and if they're the same thing, then we can say by the squeeze theorem x to the fourth times cosine of 2 over x has to approach the same value. So the limit as x approaches 0 of negative x to the fourth, we can just go ahead and directly substitute that 0 in for x, and we get 0. And we can do the same thing for positive x to the fourth, and it's going to be the exact same process. Limit as x approaches 0 of x to the fourth. Directly substitute it, so it's 0 raised to the fourth power, and it's going to be 0. So we can see now that this limit approaches 0, this left limit, not left limit, but the limit from the smaller function approaches 0, and the limit from the larger function approaches 0. So by the squeeze theorem, we can say that the limit as x approaches 0 of x to the fourth times cosine of 2 over x equals 0. And this would be your answer, this proof. Okay, so in this next problem we're asked to find the limit if it exists, and if it does not exist, explain why. And the limit we're given is the limit as x approaches 3 of 2x plus the absolute value of x minus 3. So what I'm going to do is just do direct substitution and plug in 3 wherever I see x. So I'm left with 2 times 3 plus the absolute value of 3 minus 3. That's going to be 6 plus the absolute value of 0, which is just 0, meaning our final answer is 6. Okay, so in this next problem we're asked to find the limit if it exists, and if it does not, explain why. And the limit we're given is the limit as x approaches 1/2 from the left of 2x minus 1 over the absolute value of 2x cubed minus x squared. Now this is actually a really tricky problem, so you might want to follow along to this. So what I'm going to do is I'm going to rewrite it as the limit as x approaches 1/2 from the left of 2x minus 1, and then I'm going to factor out an absolute value of x squared times the absolute value of 2x minus 1. Now, if you think about it, whatever we plug in for x, this term will always come out positive because it's x squared. So for all intents and purposes, we can get rid of that absolute value sign right there. And we're going to have limit as x approaches 1/2 from the left of 2x minus 1 over x squared times the absolute value of 2x minus 1. Now, if you think about what this means, it means we'll be plugging in a number that's smaller than 1/2, basically. We'll be getting right up to 1/2, but not quite there. So for example, if we take the point 1/4 and we plug that in for x, we'll get a negative number up top. We'll get a negative number. I'll just write a negative sign, because if we use 1/4 as our example, 2 times 1/4 is 1/2, and 1/2 minus 1 is a negative number. So we're going to get a negative number on top, and then here we're going to get a positive number, and here we're going to get a positive number because it would be the absolute value of a negative number. So we'd have a negative number over positive, which will ultimately result in a negative answer. But what is that answer exactly? Well, so because we know that whatever this will be positive no matter what, because there's the absolute value signs right there. So I'm going to rewrite this as the limit as x approaches 1/2 from the left as 2x minus 1 over x squared times 2x minus 1. And we can do that because we know that the x values will be smaller than 1/2 because it's approaching from the left. Now I can cancel these out, and I'll get limit as x approaches 1/2 of 1 to 1 over 1 over x squared. And then I'm going to directly substitute in the 1/2 because it's no longer going to give us an undefined answer. So that would be x over, 1 over 1/2 squared, which is 1 over 1/4, which if we go up here, it's the same thing as 1 times 4, which is 4. But remember, we said that our answer was going to be negative. We demonstrated that our answer was going to be negative. So we put our negative sign there, and we say that the answer is -4. And that would be my answer. Okay, so in this next problem, we're once again asked to find a limit if it exists, and if it does not, explain why. And our limit this time is the limit as x approaches 0 to the left of 1 over x minus 1 over the absolute value of x. Now to understand this one, I'm actually going to separate the two limits. So we know that from our property of limits, the limit, we can separate this subtraction thing into the limit as x approaches 0 from the left of 1 over x minus the limit as x approaches 0 to the left of 1 over the absolute value of x. So if we just look at this limit right here, we're saying that the values are going to be smaller than 0 and getting closer and closer to 0. So it's going to go from -1/4 to -1/16 to -1/32 and things like that. So we can see from that, if our values are getting increasingly negative, we're going to have increasingly, I mean, they're going to stay negative, but they're going to get increasingly smaller is what I mean. So if we take, for example, just the number -1 over 5 million or something like that, and I'm just going to abbreviate that as 5 million. -1 over 5 million is an extremely small number, and it's to the left of 0. And because of this fraction, it would become -5 million, because this is the same thing as 1 times -5 million over 1. So we can see that it's getting increasingly negative. This output would be increasingly negative. So we can say that this is going to be -infinity. And now we know that the absolute value is going to turn any value positive. So if we take that value from before, -1 over 5 million would just become +1 over 5 million, and then our output would be 5 million. So in this case, our answers would be increasingly positive, or increasingly larger. So this limit would be infinity. So now we have -infinity minus infinity, and we can't really do that. That's not something you can do in math. I guess you could write it as -infinity again, because you're just subtracting two very, very large negative numbers, or very, very small numbers. But ultimately the answer would be does not exist. Okay, so in this next problem we're asked to evaluate the limit if it exists, and the limit we're given is the limit as t approaches 0 of the square root of 1 plus t minus the square root of 1 minus t all over t. So the first thing you're going to want to do when you see any problem like this with the square root in the numerator is you're going to want to multiply by the conjugate. And what the conjugate is it's basically what you see in the numerator, except you change the operator that divides the term, that separates the two terms. So I'm going to keep everything the same, except I'm going to change the minus into a plus. And if this had been a plus, I would have changed it to a minus. And I'm going to multiply, and that's called the conjugate. I'm going to multiply by the conjugate on the numerator and the denominator. So it looks like that. And then I'm going to basically multiply together the terms here. So what I'm going to be left with is 1 plus t plus the square root of 1 plus t plus the, or not plus, times square root of 1 minus t. And I got the 1 plus t because 1 plus t, the square root of 1 plus t times itself is the same thing as the square root of 1 plus t squared, so the squared and the square root would cancel out there. Now when we do this, it's going to be minus, and then we're going to have this same term here just over here, because we're multiplying by the same things basically. So it's going to be the square root of 1 plus t plus, times the square root of 1 minus t, and then plus 1 minus t. And I'm going to bracket this off because the minus sign is going to distribute to this term as well as the 1 minus t. And that's all going to be over t times the square root of 1 plus t plus 1 minus t. Now if you take a look at this, like I said, we're going to distribute this minus sign. So this is basically square root of 1 plus t times the square root of 1 minus t minus the square root of 1 plus t times the square root of 1 minus t. In other words, if I let a equal 1 plus t, square root of 1 plus t, and I let b equal the square root of 1 minus t, I can see here that what I have is ab minus ab. So these end up canceling out. And so I can rewrite the equation as, or I can rewrite the limit as 1 plus t minus 1 plus t. Remember, because the minus sign distributes to the 1 minus t term as a whole. So it's like saying this. So it distributes to both of them, making it minus 1 plus t. All over t times the square root of 1 plus t plus 1 square root of 1 minus t. So this 1 and negative 1 are going to cancel out, and this t and 2t are going to add together to give me, or this t and t are going to add together to give me 2t, giving me 2t over t times the square root of 1 plus t plus the square root of 1 minus t. And I can see now that these t's will cancel, giving me limit as t approaches 0 of 2 over square root of 1 plus t plus the square root of 1 minus t. Now I can go ahead and directly substitute in 0 for t. So I'm going to rewrite this as 2 over 1 plus 0 plus 1 minus, plus the square root of 1 minus 0. So the 1 plus 0 is just 1, and 1 minus 0 is just 1. So I have 2 over the square root of 1 plus the square root of 1. The square root of 1 is just 1. So I have 2 over 1 plus 1, which is 2 over 2, which is 1. So that would be your answer. Okay, so in this next problem we are once again asked to evaluate the limit if it exists, and the limit we're given is the limit as x approaches 16 of 4 minus the square root of x all over 16x minus x squared. Now what I'm going to do first is I'm actually going to simplify the denominator. So I'm going to make it 4 minus the square root of x over, and then I'm going to factor out an x, and that's going to give me 16 minus x, right? Because x times 16 is 16x, and x times negative x is negative x squared. So now that I've simplified it, I'm going to once again multiply by the conjugate, something you want to do whenever you see a square root in the numerator like this. So it's going to be 4 plus the square root of x over 4 plus the square root of x. So what I'm going to have here is the limit as x approaches 16 of 16, and then so basically what happens is you go 16 and then you go 4 times square root of x, and then you go negative 4 times the square root of x, and those would end up canceling out. So I'm not even going to write those terms, and I'm just going to go to this negative square root of x times square root of x term. So that would give me negative x, right? Because negative square root of x times x is like saying negative x squared, and these things would cancel out, giving me negative x. So 16 minus x over x times 16 minus x times 4 plus square root of x. So these will cancel out here, giving me limit as x approaches 16 of 1 over x times 4 plus root x. Now I can go ahead and substitute 16 in wherever I see x, giving me 1 over 16 times 4 plus square root of 16. And then square root of 16 is 4, so that's going to give me 1 over 16 times 4 plus 4, which is the same thing as 1 over 16 times 8, which is 1 over 128. So that would be my final answer for this one. Okay, so this next problem, we're given the exact same instructions, just a different limit defined. So the limit we're asked to find is the limit as t approaches 0 of 1 over t times the square root of 1 plus t minus 1 over t. So the first thing I'm going to do is get this into a like denominator. So I'm going to multiply by the square root of 1 plus t in the numerator and the denominator. And I'm going to make this the limit as t approaches 0 of 1 over t times square root of 1 plus t. And then this is going to be minus square root of 1 plus t over t times the square root of 1 plus t. So now that these are like denominators, I can actually go through with the subtraction process and make this limit as t approaches 0 of 1 minus the square root of 1 plus t over t times 1 plus t. T times the square root of 1 plus t. So now this just looks like another multiply by the conjugate problem. So that's what I'm going to do. I'm going to multiply by 1 plus the square root of 1 plus t. And I'm going to do that in the numerator and the denominator. So that's going to give me limit as t approaches 0 of 1 minus 1 plus t. Like that. And then this is going to be t times the square root of 1 plus t times 1 plus the square root of 1 plus t. So this negative 1 is going to distribute to the 1 and t. So this is going to become limit as t approaches 0 of 1 minus t over t times the square root of 1 plus t times 1 plus t, square root of 1 plus t. So I'm going to rewrite this over here. So basically this 1 and negative 1 are going to cancel out, leaving me with limit as t approaches 0 of negative t and then this is going to be t times square root of 1 plus t times 1 plus square root of t. So now this t and this negative t up here are going to cancel out, and if it's not clear why, let's do the same variable example that we did a couple problems ago. So let a equals t, b equals the square root of 1 plus t, and then c equals 1 plus the square root of 1 plus t. What we have here is a over abc, a times b times c. So we can just cancel this out and get 1 over b times c. So that's what we did. So I can rewrite this as limit as t approaches 0 of 1 over square root of 1 plus t times 1 plus the square root of 1 plus t. And now what I can do is I can directly substitute 0 into the equation. So that's going to give me 1 over 1 plus 0 times 1 plus 0. So 1 plus 0 is 1, and the square root of 1 is just 1. So I'm going to rewrite it as 1 over 1 times 1 plus 1, which is just 1/2. So that would be your answer for that one.